All right, today we are going to go over the circuit diagrams and how to actually diagram number 1 and the number 2 boards. Number 3, 4, and 5, you guys are going to do on your own, but you can practice them, draw them out. We're going to do it electronically, so I can kind of show you how I'm going to do that. So that way we don't mess up our paper that we're going to have. We can actually put the correct diagram on the paper, so that way you have that when we're in lab to actually reference from, so you know how to actually wire those things. So 1 and 2 we're doing together. 3, 4, and 5 you guys are going to do on your own, using some of that knowledge and building new things from that. So to start, we're going to go ahead and share the screen, so that way you can see what that circuit diagram looks like. So if we can find the share screen now somewhere, there it is. We're going to go ahead and share screen 2. So what you'll see here on the screen is basically the introduction to your circuit diagrams. There are 10 different boards that we're going to do. Number 11 is going to be an extra credit. A couple of things that we want to kind of make note of is the key that we see right here in the middle of the page, and how we're going to actually, draw these things out. I prefer to do it in color, just because it makes a little bit more sense of where things are going to connect, how they're going to connect to those things, how we're going to actually wire stuff up. But you can do this with just pens, pencils, things like that. There are a couple color of wires that we need to be worried about. The first one is going to be the white wire. You can either use a pencil for these. White really doesn't show up on my white background, so we typically will use yellow. So if we're going to use the color yellow, understand that that's indicating our white or our neutral wire that within our diagrams. Black wires can be done with either a pen or the black color pencil. We're going to actually do this in paint, so you guys will have the option of being able to do it in paint as well. All I did was just take a screen capture and then put that, upload that into paint, and it allows me to kind of draw those things out electronically. So if we make mistakes, we can kind of go back, we can kind of fix those things. So black wire, either black pen or black color pencil. For the green wire, we can either use a dotted line or we can use a green color pencil. We're going to obviously use the color green. This is going to indicate both green insulated wires and then bare copper wires. They are both your ground wires. We're going to represent those with green. Red wires, you can either do a little swirly line or we can use a red color pencil. That's exactly what we're going to do on here. On you see these diagrams, you're going to find and see that there are different types of terminals. Brass terminals are going to be represented by a black circle that's filled in. So a solid black circle is going to be any brass terminal. Those are going to be our hot terminals on our systems. We have silver terminals, which are represented by an open circle. So it's just a white circle with a black outline. Any of the ground terminals, those are going to be the green screws that we have on the equipment and the boxes, are going to be represented by a circle with a G in the middle. The common terminals, those ones we're going to get into when we talk about 3-way switches. And then if we do the extra credit, the 4-way switch, you have the I and O's within those circles, the dark circles. Those are going to indicate hot terminals, but your common and your input and output. So the first couple of diagrams, we won't need to worry about commons in inputs and outputs. It's really just going to be the brass, silver, and the ground terminals that we're going to worry about. We'll talk about 3-way switches and how we wire that and what those common terminals mean in another video there. So beyond that, if we kind of scroll down, we can kind of see that we have each of our diagrams, diagram number 1, diagram number 2, diagram number 3. They're all slightly different from each other as we go through. There are different things. The goal from here until number 6 is we should be able to wire those up. Number 6, we get into 3-way circuits or 3-way switches. They're a little bit different. Again, we'll have a video covering those, and then you guys will do the rest of those on your own. Same kind of thing. You can try them out, test them out, see if you got it, send it to me. If they're not right, we'll make corrections. But I want you guys to think. I want you guys to use your head and think about what you do know versus maybe what you don't. We're going to pull up paint right now, and we're going to pull up diagram number 1, and we're just going to kind of go through this system in paint. So again, I took a screenshot of that, and then I inputted that screenshot into the paint program, and that allows me to grab these brushes to do different colors within there, and that's exactly what we're going to do. One thing that is going to be common with every single diagram that you are always going to have a source wire. There's going to be a plug that we're going to plug into a wall. That's where we're getting our power from. That's what we're calling our source. That source wire in every single one of these diagrams is going to be exactly the same. You're going to have these three colors every single time. You're going to have a black wire. We're going to draw that out there. We're going to have a white wire. This is going to be our neutral wire. And then we're also going to have a green wire. If I can do this, let me see if I can make this a little bit darker here. And then we're going to have a green wire that's going to be in there. So every single source wire is going to have those three colors. You are never going to have a red wire coming from your source in these diagrams. So every single one of these, that's where we're getting our power. So our hot power is coming from our black wire, our neutral is coming from our white wire, or our yellow mark there, and then the ground wire is going to be the green. That ground wire could be a bare copper wire if it's Romex, or if it's like an individually stranded wire, it could have a green coating. It is still your ground wire every single time. Now, what's important to note on this is to understand what these diagrams are actually asking us to do. So in the number one diagram, we have an SPST, otherwise known as a single pole, single throw switch. That switch needs to switch on to control the light socket. So this switch in this first box needs to control this light in the second box. Now, if you remember back from the other videos on how to wire, we kind of talked about where these wires are going to go. This is a pretty basic and a pretty simple circuit. Essentially, what we need to do is we need to connect all the hot wires onto our brass terminals, and the neutral wires essentially need to carry things back. So we're going to kind of go through this kind of step by step. I'm just going to kind of show you what we need to do. We'll do diagram number 2, which is going to be a little bit different, and we'll show you those things. So on these systems, the hot wire is going to be supplying the power into that system. What we don't want to do is we don't want to go directly to our light. We want to take our hot power and go into our switch. And on our switch, you can see that we have 2 hot terminals right here, and we also have a ground. There are no neutral terminals on these switches. So essentially what we need to do is we need to connect our source wire into our switch. Now, it doesn't matter which side of this switch we connect to, because all this switch is doing is connecting those 2 brass terminals and disconnecting. So it's just connecting and disconnecting. When we flip the switch on, it connects this terminal with that terminal. So to carry this power on, we're going to have wires that are going to be running into here. And because there is no conduit, you can see some conduit right here represented by these lines, we're going to be using the non-metallic cable clamps. That means we're going to be using Romex wire. So Romex wire is going to have 3 different colors. We're going to either have a black, white, and a ground, or black, white, red, and a ground. Which one we use is determined by the system that we're actually putting in and how we're going to actually get those things set up. So what we're going to do is we're going to take that power back from our switch, and we're going to go into our light socket here. When we put that into that light socket, that's going to give us power from our source into our switch. When we turn the switch on, power is going to go into our light. Now, the only thing that we need to do from here is we need to actually take and carry this thing back, and I can't see this thing, so we're going to minimize this. We can select this. So what we need to do is we need to take the neutral terminals and we need to carry those things back into our neutral wire on the source. So we're going to do that by grabbing this outlet right here. We're going to bring this thing into here. And we don't want to have this wire going straight through within these systems. We want to make a connection, and that's where our wire nuts are going to come in. We don't actually have any terminals we need to connect to on here. So we're going to bring these 2 wires together. And then I like to draw like a little box. What that indicates, that box indicates, is that it is a wire nut that we are connecting those things together on making that connection. We don't want wires to run straight through in that box. This is going to be Romex. This is going to be a different wire. We can't just have them joined together. We have to actually wire them together using a wire nut. Now, if we were to follow this path, we could see that power is going to come into our switch. When we turn the switch on, it's going to go into the other side of the switch, which is going to carry into our light. It's going to go into our light. It's going to come down, and it's going to be able to return. For an electrical circuit to work, you have to have a circuit. So it has to come out, it has to use some of that power, and it has to come back. So it's got to go through a load. In this case, our load is our light socket. So that is what we're using as the expended energy is coming back. If we have a black wire, a hot wire, and a white wire touching, it's without going through a load, it's going to cause a short circuit and the breaker is going to pop. Hopefully the breaker pops. If not, there's another issue that we have. So in this system, power comes in, goes to my light, it's able to return. This light would work. The one thing that we do not have grounded is all of our green screws, our green terminals, okay? So we have the green screw in the bottom of both the boxes and on our single pole, single throw switch. Now, what we don't want to do is we don't want to take this green wire and just wire it up to here and then wire this thing up to there. Even though all the green screws are connected, these two are not connected and not everything goes back to our source. So these things would be incorrect. This is not a correct way. A lot of people tend to do this. So we're going to just get rid of those things and do this thing the right way. So what we're going to do is we're going to come into this box and we're going to do a little wire nut. So we're going to do as best of job as we can making a square. And then we're going to take these little pigtails that we talked about. So those are 6 inches of wire that's going to be connected in. Those little pigtails, we're going to connect those two into the wire nut, carrying back to our source. The only thing that we need to do now is actually take the ground screw right here and connect that into our system right here. So now what we've created is a web. Every green screw, I can draw a path to every green screw, and every green screw is connected. So within that system, every green screw needs to be connected. You'll notice down at the bottom that we think we have these things that says nothing in this box. We're imagining that those things do not exist. They are not there. We don't need to wire those ground screws up to that unless there's a piece of equipment in a box. So this is a system where these things are irrelevant. In future diagrams, we're going to use some of these other boxes. We just need to be aware of that. So if we're using the box, we connect the ground. If not, that's it. So this is diagram number 1. This thing is going to work perfectly. This thing is pretty simple. It's pretty basic, but that's essentially what we're doing. We need to think in terms of a path. So coming out and then coming back in. If you guys have questions on that, feel free to, let me know and we can try to answer those questions as much as possible to help you guys out. But this is diagram number 1. When we go in class, you're going to wire these things up. This is exactly what you guys need to do. So you can copy this down on your paper so that way you have it. So diagram number 2, this is very similar to it. We have a single pole, single throw switch that needs to control the light socket. This thing says that you must bypass the light socket first. So you notice that the equipment just flipped. Our source is still in the same location. Our source is still exactly where it needs to be. That has not changed at all on these systems here. So every single time we are going to have a black wire, a white wire, and then a green wire. And my share screen is like popping up and I can't see the rest of the system here. Let's do this here. There we go. Now I've got that stuff figured out. Okay. So we're going to have a black, a white, and a ground wire that's going to be coming in. That's every single diagram. That never changes. Now, there's our goals. We need to create a circuit. We need to go into something, and then we need to have that stuff returned. This, we do not want to do. This is going to be incorrect. And this is where a lot of people want to do is they want to take our hot wire, connect it just like we did, right to our light. The problem is when we go to take our neutral wire back, I don't want that on the green. When we go to take our neutral wire back, if we were to do it like this, what's going to happen is power is going to go into our light and then it's going to cycle back through. We have no way of switching this power off. So this light socket is always going to be on. So what we're going to do, like the diagram says, we're going to bypass these things. What we need to do is take a wire nut. We're going to take our black wire. We're going to carry it into our switch. So we're bypassing our light, going into our switch first. Then what we need to do is come back and go into our light. There's a problem that we're going to have and we're going to run into. If I were to take this other switch, this other brass terminal, and connect this back to my light, the problem that I have is now, if I drew a line right here, I have 2 black wires running in between these 2 boxes. That is a problem, especially when we're dealing with Romex. Romex is going to have one black, one white, and a ground, and sometimes it's going to have red. It doesn't have two black wires. It doesn't have two white wires. It doesn't have two red wires. It has one of each of the colors. And that is true of any of the systems. If you were to draw a line across any of these, you should never duplicate wires. I should never have more than one color wire crossing this. From one box to the other, and one box to here, I can have a black wire here and a black wire there. That's not a problem. But in between the two boxes, I can't do that. So although this is the correct way for us to wire it, we actually need to change this black wire here, and we're going to actually use a different color. Now, I could use a red wire, but in this system, if I were to take my neutrals back, remember in our switches, we have no neutrals. This does not need a neutral wire running in here. Romex is going to have a white wire every single time. But in this system, in this case, we do not need that neutral, that white wire as a neutral. So what we're going to do is we're going to actually take that white wire and we're going to turn it into a hot wire. We're going to wire that up as if it was another black wire. We want to mark on every terminal end with black. We're going to use black electrical tape. That's going to indicate that that white wire is being used as a hot. We mark it in this box, so that way if all I see is this box, I don't see a white wire that's being connected to a hot terminal and think that it's a neutral terminal. So what I'm going to do is I'm marking it with black electrical tape. That's very important because you're going to lose points if you don't do that. You need to indicate if it's being used as a hot. And you often will do that in some systems. You will see this in some of these systems later on. If I had a neutral wire here, I would need to connect that with a white wire. In that case, I would probably then need to use a red wire, and that's when I would grab the different Romex. But in this system, we don't need that. Now, if we were to trace this power in, we would go into here with our power, into our switch. We flip our switch on. It goes into this neutral wire being used as a hot, goes up into my light, goes to my light, and it's able to return, and it's able to come back. This system will work. You will turn the light on with that switch. Okay. The one thing that we are missing is the ground wires. Now, the ground wires don't typically change much at all. All we're trying to do is come in. We're going to do a wire nut like we did before, and we're going to connect every green screw. We're going to have a wire that comes into here. We're not going to go directly to our green screw. We're going to do a wire nut because I need two pigtails that are going to connect these things together. So now I've created my web with my grounds. Every green screw is going to connect. That never changes in any one of these diagrams. That is always the exact same. All the green screws are trying to connect to each other. You are never going to use a green screw or green wire as a hot wire. You're never going to use it as a neutral wire. They are always going to be the ground screw with ground terminals, ground wires. Okay, no matter what, green or bare, they never change. The white wires sometimes do, depending on the system. Okay, and sometimes we add red wires. Sometimes we add blue. We don't need any blue in the cases of these diagrams, but in some wiring diagrams, you would, where we have more power and more stuff coming through. So this diagram is complete. We now have this thing finished. We have it completed. There's one thing that I want to make a note of, and this is true of both light sockets and as we get into the duplex receptacles, and we'll pull up this thing so that way we have an example of it. On the duplex receptacles, you'll notice there is a line connecting both the hot terminals and the neutral terminals. The light sockets have the same thing as well. Those are connected with a metal plate. So if I connect one of these screws with a hot wire, the other terminal will also be hot because there is a metal plate. That is different than the switches that they only connect when the switch is on. On duplex receptacles, the brass or the hot wires and the silver or the neutral, wires or terminals, they are always going to be connected because there's a metal plate that connects them. Sometimes we can use that as a wire nut. So I can wire one neutral to here and one neutral to here, and that's going to allow me to carry things on or carry it past these systems. You don't need to connect to both of them. If you connect to one, it connects to both. So in the case of these diagrams that we did, I just connected to one brass terminal. It doesn't matter. Connected to one or connected to the other, they will still be connected. So that's the first two diagrams. When you start getting 3, 4, and 5, my suggestion is go with 3 first, try that out, and you can talk with me. We can try to figure those things out. They are similar, but they're not the same. Okay. The one thing that I will tell you is that on the number 3 diagram and anyone kind of 4 and 5 as well, these duplex receptacles need to be hot, meaning they are always on. The switch will not control the duplex receptacle. The switch will control the light. So these things always need to have power, just like you have at your home. When you plug your phone in, you can charge it at night, but you can turn your light switch off so that way you can sleep without having the lights in, because most people do that. That's a pretty standard thing. So 3, 4, and 5, you guys are going to do on your own. You're going to have this in your Canvas. You're going to have access to this. Again, take a screenshot of it, do it in Paint, draw it in Paint, save that, send it to me, and I can take a look at it, and we can talk about what's good, what's bad, what we did right, and what things we need to correct. And if you're right, we're good to go, and then you'll be able to wire up that board. All right, so that's the diagrams. That's what we need to work with. We're going to show you number 6, and then that'll give you the rest of the information, so that way you can wire up the other ones. And then number 11 is an extra credit one. I don't show you guys how to do that. That's something that you have to go above and beyond and do that. But you don't have to. It's just an opportunity for you to earn some extra credit. So thanks, guys.